Welcome back, students. Now we will see another topic in unit number 3, that is resolver, synchro, and microsyn. So these are the three sensors, three identical sensors. All three are very similar in construction and similar in its working principle. Only difference is it is all three are measured for angular type of displacements, and the angle only differs. The angle is 90 degrees in case of resolver, whereas it is 120 degrees in case of synchro. That is more than that in microsyn. Then we will move on to encoders, optical, magnetic, and captive type, capacitive type. These are the topics left out in our third unit: accelerometer, GPS, Bluetooth, range sensors, and beacons, reflective beacons, and lidar. So these are the topics we are about to cover in this unit. So resolvers also work on the principle of mutual inductance. So it is also a inductive type of sensor. Mutual inductance variation, and are widely used for measurement of rotary motion. A resolver consists of a rotor containing a primary coil and two stator windings. So it is also very similar to LVDT, like one primary coil and two secondary stator windings with equal number of turns placed perpendicular to each other. The rotor is directly attached to the object whose rotation is being measured. If AC excitation of RMS voltage VR is applied, then the induced voltages at two stator coils are given by this simple relation, that is V01 equal to kVR cos theta, V02 equal to kVR sin theta. So sin theta, where k is a constant. So this is a simple relation for this rotary measurement. The voltage induced in A is in quadrature at 90 degree offset to the voltage induced in C. So that I will show you in diagram. Using the output of the two windings gives an absolute position, since each position has a different combination of A and B. The frequency also changes with the velocity, and you can also determine the velocity. So the data output from the two phases is usually converted from analog to digital by means of a resolver to digital converter. Resolvers typically achieves a resolution up to 65,536 counts per revolution. By measuring these two voltages, the angular position can be uniquely determined, provided phase sensitive detection is needed if we want to measure for angles in all four quadrants. So by quadrant wise we can measure the rotary motion. So here theta is lesser than 0, theta is greater than 0 and lesser than 90 degrees. So that is the angle within which you can measure. So you can see here, this is the stator and this is a rotor. This is another stator. These two stators are at 90 degrees to each other, and here this is kV0, right? This is output voltage. Output voltage is measured along this stator, and along this stator it is V reference into cos theta. This becomes sin theta. Simple trigonometric principle here, and this is the theta, and this is the rotor, and AC supply is given to the rotor. It is similar to LVDT only, whereas only difference is the rotor is placed, and rotor can be varied from 0 to 90 degrees. This is a simple resolver construction. Next improvement or next type of rotary motion measurement is done by synchros. So synchros work widely as error detectors in position control systems, and this is very important application of synchro. It acts as error detector in position control systems. The principle of operation of synchros is similar to that of resolvers. A resolver is a form of synchro in which the windings on the stator are displaced mechanically by 90 degrees to each other, whereas in synchro it is 120 degrees. So that is the angle is more within which we can measure the rotary motion. Resolvers are used most often as angular displacement transducer. So this is the construction. You can see the stator 1 and stator 2 are at 120-degree angle, and stator 2 and 3 are faced at 120 degree apart, and now this is 240 degrees from 0, and the angle between these two stator 1 and 3 is also 120 degrees. So stators are placed at 120 degrees apart. So that is the construction of very similar to resolver, and here only that angle getting increased. So here this is excitation voltage, and V output is taken from any of these stators, and the input is given to the rotor. Input is given to rotor. So that is the simple construction. It is very similar to our resolver. Next one is Microsyn. Microsyn is another type of transducer. The variable reluctance transducers are based on change in reluctance of magnetic flux path. So it is also a inductive type of sensor. Commonly used example of variable reluctance transducer is the Microsyn. A microsyn consists of a ferromagnetic rotor and a stator carrying 4 coils. A stator coils are connected such that at null position the voltages induced in coils 1 and 3 are balanced by voltages induced in coil 2 and 4. So 2 and 4 and 1 and 3 are both the odd number coil and even number coil are balanced here. The motion of the rotor in one direction increases the reluctance of two opposite coils while decreasing the reluctance in others, resulting in a net output voltage. The movement in opposite direction reverses this effect with a 180-degree phase shift. So this is the construction. You can see here this is the rotor iron core, and input is given through 1 and 2, and output is taken from 4 and 1, and here the three windings here are placed at 90 degrees with each other. So this is the simple construction of Microsyn. The uses of Microsyn can be: Microsyn transducers are used extensively in applications involving gyroscopes. By the use of microsyns, very small motions can be detected, giving output signals as low as 0.01 degree of changes in angles. So that is the very small motions can be detected, and the sensitivity of the device can be made as high as 5 volts per degree of rotation. The nonlinearity may vary from 0.5% to 1% full scale value. The main advantage of these transducers is that the rotor does not have windings and slip rings. The magnetic reaction torque is also negligible here. So that is the Microsyn advantage uses. And here these are the three similar type of transducers, and each one is having its own application and its own importance. And when you see Microsyn, it is having more sensitivity compared to other two types of transducers. So there ends this topic. For books, you can refer these books. Dioblin, Patranibus, and also A.K. Ghosh can be referred for these topics. We stop here, and we will see in another topic in next session. Thank you students. We stop here and we'll meet again.